Someone grab the lights, please. All right, ladies and gentlemen, let's take a look. Somebody on the lights? Anybody on the lights? Thank you. Okay. Any questions on 1, 2, 3, or 4? 1, 2, 3, or 4? Any questions? 1, 2, 3, 4. Yo. Great. Number 5. All right. And our statements. All right. 1, 2. I'm going to put 1, 2, and 3 on my givens just to save space. All right, and then we're trying to prove those two triangles. So when I'm looking up at these triangles, what should you kind of see right away without even looking at the givens? Yeah.
The two angles. Okay, so angle BCA and DCE.
There you go. Yeah, because they're vertical angles, right? So just what you're not even looking at the givens, you should be able to see that you have vertical angles up there. So your fourth statement on here probably should be angle BCA is congruent to angle ECD, and that's E. That's a C. Sorry about that. And that's vertical angles. All right, so we already know that. Now we can start looking at our givens, but that should be something that is a go-to for you right away. Okay, and then it talks about AB. So then you have these segments from your givens. AB. So A to B is congruent to D to E. Okay, that's part of your givens. And then they also tell us that BE and AD are perpendicular. So now this really kind of goofs things up. So now you have that being perpendicular. Okay? So yes, these were congruent. Those were my go-tos, but now they tell us that they are vertical angles. So I guess you could say that angle BCA and angle ECD are equal to 90 degrees. And, you know, definition of perpendicular, something like that. So now you have perpendicular lines, so you have a 90-degree angle. So then you have to start thinking, okay, is it going to be hypotenuse, leg to prove these triangles? So of our AB and our ED, are those the hypotenuse or are those one of the legs? Hypotenuse or legs? Is this the hypotenuse to the triangles or the one of the legs? Hypotenuse, yeah. So think of it this way. This arrow points to its hypotenuse, the 90-degree angle. Okay? And then the last thing that they tell us is C happens to be the midpoint. C happens to be the midpoint of AD. So now we're talking about this portion and this portion. So C is the midpoint of that, so we can go ahead and state that segment AC is congruent to segment CD or DC, however you want to write it. And that's definition of, that's 1, 2, and 3. And there should have been 4 right there. That should have been 5 there. Sorry about that. And that's definition of midpoint. So now, do we have enough information to justify these triangles? Absolutely. Okay? Not side angle side. What is it? No, well, angle side side appears to be listed up there, but we can't use angle side side. Hypotenuse leg. So step number 7, this is hypotenuse leg. Okay? Now, notice hypotenuse leg as it is written, it is indeed angle side side up here. So this could be a case to say, well, angle side side does work, but we know that angle side side isn't working for everything. Yeah?
Isn't the given for number 7 HL postulate? Wouldn't we call that?
Oh yeah, I could say HL postulate or just HL. I'm with you on both. So just to stay in the whole thing of angle, side, side, things like that. 1, 2, 3. Are any of the others on 1, 2, 3, or 4? You okay with any of this? Yeah. 4. All right, number 4. So what's your go-to looking at this picture? What's the go-to that you should have automatically? Yeah, you got a reflexive property taking place without even putting the givens or anything yet. You just have that. Sprinklers. All right, so let's see. 1 and 2, we already know these are our givens. Again, I'm just putting that to save space. So AB is congruent to AD. And then they tell us that the other given is AC bisects angle BAD. So that's going to tell us, so this one tells us that we have a bisector of an angle. So angle BAC is going to be congruent to angle DAC. And that's because of definition of bisect. Okay? So then we should go to our reflexive. AC is congruent to itself. And that's for a reflexive property. What does it appear we have? We have a side, an angle, and a side in that order. So we can go ahead and prove the triangles are congruent. So triangle ABC is congruent to triangle ADC because we know a side, angle, side in that order. They're blowing out the sprinklers outside.
They blow out the sprinkler.
They are. It looks like this.
It sounds like blow up the dying or something.
Got pulled. Okay, on the back side. Any questions on 5, 6, 7, 8? Yeah. 7, you got it. All right, problem number 7. What's a go-to on number 7 without even looking? Yeah.
Was it like possible to have like 2 like outcomes, like side angle side and side side?
Oh, absolutely, yeah, definitely. So a go-to here is you should realize that this angle and this angle are congruent without even looking at your givens because of vertical angles. Is it something we need? I don't know, and that might result we have multiple things to say, which that's fine. So we have 1, 2, 3. We have 3 givens, or statements, and reason. So 1, 2, and 3 are all givens. So they tell us that AB is parallel to ED. So this is parallel to this. If it's parallel, does it mean it has to be the same in length? No, it just means it has the same slope to it. It's not going to intersect. Okay? But things that should be go-to when you have that is you should start realizing, wait a minute, just by statement number 1 alone, I know that this angle here and this angle here have to be congruent because they are what? They're alternate interior. So you could go ahead and state that without a problem, saying angle BAC is congruent. So BAC is congruent to angle EDC. And we can say that we have alternate interior angles. Okay? I don't even know if we were supposed to go there yet. But I could also justify that step number 5, I could say that this angle here is congruent to this angle here. And again, I haven't even gotten past my first given. I just know those things are going to take place. So that's going to tell me that angle ABC, yeah.
Instead of putting BAC and is congruent to BDC, couldn't you just say angle A and angle D are congruent?
I guess so, but I was just trying to. I like labeling with triple angles. The only time I'd like to go with a singleton is maybe if these were completely separate shapes. So ABC and DEC, but you're not wrong if you do. And again, that's alternate interior angles. Okay, and then I do have my go-to of my vertical angles just by my diagram. I mean, again, I haven't even looked at my next given. I'm just listing things that I know in hopes that something comes out. So then I have BCA is congruent to, so BCA is congruent to ECD. And we can say that because of vertical angles. Bless you. So, angle, 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 does that prove triangles are congruent? No, so that's not going to really help us. But again, I only had looked at my first given and my drawing so far. Well, let's see what else we know. So here's a sweet thing. I already have angle, angle, angle. All I need to have is something inside it. Let's see. Can we say our second given is AB is congruent to ED. AB is congruent to ED. Okay, what have we proven so far? We have side, 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 hypotenuse, leg, and what's the other one? Side, angle, side, right? Side, angle, side, hypotenuse, leg, and side, side, side. Well, no. I need to find a second side. And then AD is the bisector. AD is the bisector of this. So it cuts this right here in half. So then my last statement I need to say, as far as this goes, is BC is congruent to CE. And the reason I know that is definition of bisector. So that's going to tell me that and that. So do I have side angle side in this particular case? I do. I do. So then I can go ahead and state triangle ABC is congruent to triangle DEC. And the reason we can say that is we have proven side angle side. Now today we're actually going to learn angle side angle, so that could have been proven on angle side angle, but we're not there. Okay? Is there redundant stuff? Is there stuff up here that I don't necessarily need? Well, side angle side, I did not need this. Was it wrong to put it? No, it's just that you're recognizing patterns out there that are taking place. Did I need this one? No, that one didn't. We didn't recognize it, but we were okay. I mean, as soon as we had parallel lines and transversals, those alternate interior angles just kind of happened to work. So theoretically, we could have had this done in 1, 2, 3, 4, 5, 6 steps, but I took 8 to get there. Why did I take 8? Because I recognized certain patterns of here and here and here and here. That was okay. I recognized this pattern, but that's okay. So you're just trying to get to one of our 3 go-tos right now, and we have more that we're getting to. Any other questions up through number 8? Yeah.
Number 6.
6. Just looking at the diagram, what should we have as our go-tos? Yeah, OY, OZ, because they're the radius. Okay, I don't have to list it yet. What else do we have just because of our diagram? Not just because of the circle. Go ahead.
OX.
OX reflexive. Exactly. So we have some things in mind. Do we have to put them yet? I don't know. Let's see what our givens lead us. Step 1, circle O. Good, Kevin. And then we have 2 and 3. These are all part of our givens. Okay, so let's see what we can get to. Okay, circle O. So just by the circle O, just by this one, we can have our go-to say that OY is congruent to OZ, and that's definitely, we can put radii. I understand what you mean with it. You talk about that. Okay, does that enough to solve the problem? Oh, I don't know. Maybe we don't even look at our second given yet. We put our obvious just from our diagram that OX and OX are congruent because of reflexive property. That might be our given, or all our go-tos. Okay, we might have overproven it. So right now, there are things that we're thinking. I mean, we have hypotenuse, leg. I don't know if they're. I don't know if we know that they are right triangles at this point. We have side angle side, and we have what's the other one? Side. Okay, so right now I have two sides. So we can either prove inside here and inside here. It would be great if we could prove that that's a right angle and that's a right angle. Yeah, hey, you want to know what though? I knew they were perpendicular without even the givens. Why do I know that?
Dang, son.
Yeah, baby.
He's a savage.
What does a tangent line to a circle do to the radius? Maybe you didn't know this. What is a tangent line? A secant line touches a circle twice. The longest secant, a chord is a line segment that touches a circle twice within the circle. Longest chord is the diameter. A tangent line and a radius is always perpendicular. Okay, a tangent touches the circle one time. Okay, what does the TAN version on your calculator mean? Well, tangent with that deals with the opposite over the adjacent sides of the triangle you're dealing with, but that tangent also has something to do with it. But they did tell us with our givens that OY is perpendicular and OZ is perpendicular. Okay, so then we could easily state that angle XYO and angle XZO equal 90 degrees. Definition of perpendicular. So you have this and this. Oh, now I have a right angle. Do I have hypotenuse leg?
Yes.
Yeah, this points to the leg. This points to the leg. We have hypotenuse leg. We can prove these two triangles are congruent. So we have triangle OYX is congruent to triangle OZX. And hypotenuse leg, HL works perfect. Okay? And if you didn't know, there's no reason that you would know that a tangent line forms a perpendicular with the radius. Maybe we'll discover that later in the class. Way.
No way.
Way is there. 9. Anyone want to see 9? You want 8? I'll do 8. All right. Number 8. What's something that you see right away up here?
Reflexive.
Yeah, you got a reflexive property. Is it going to solve it? I don't know. Okay, so it looks like we have 2 givens. Okay. Let's start going off of what the givens might have said for us. They tell us that XZ is perpendicular to YW. Okay, so that's going to tell us that angle ZXW and angle in ZXY are equal to 90 degrees. And that's definition of perpendicular, right? Hey, once we've said that we have two 90-degree angles, do we have to say those angles are congruent, or is it a little bit redundant? Redundant. Of course, if 90 is equal to 90, well, duh, they're equal to each other. You could tell me that they're congruent, but it's not necessary. Now that we know we have a 90-degree angle, what are we starting to try to focus on? Hypotenuse leg. So having this take place, we should be thinking hypotenuse leg right now because we're talking about 90-degree angles. So we know WZ is congruent to YZ. That was part of our givens. And then we have our reflexive property, absolutely. Excuse me. Woo! All right. Do we have enough information to say these two triangles are congruent to each other? Yep. So I have triangle WXZ is congruent to triangle YXZ. Why is that? Hypotenuse leg. Sweet. We good? Happy? Sad? All right. If you would, two things. Make sure your name is on it and staple it and bring it on up, please. Yo. Okay. Here we go. So 4.5, prove a triangle congruence with angle side angle and angle side. Okay, angle side angle means you have an angle, and in between those two angles, that side's equal. Angle side means you have two angles, and one of the sides that's not in between those angles is congruent, and that proves that triangles are congruent to each other. So that we're adding to our list. I mean, we have hypotenuse leg, we have side, we have side angle side. Now we have angle side angle and angle side. So there's a lot there to go through. All right, what methods are we now proving? So we got it. You know, I just wrote what we did. Hypotenuse leg, side, side angle side, and the two new ones. What ways do not work? Angle, and our favorite. Yes. Okay. Angle side doesn't work. Angle doesn't work. Okay. But we did prove one way, or we saw one way that angle side does work, and that happens to be one of the ways when we have the hypotenuse leg that tends to work when we know the. So, for those of you who are offended by this, you can go with the SSA. And then hold it up in a mirror, and you see that it's spelled backwards.
No, don't let butthurt people get their way. Whoa.
Alright.
Get it, butthurt.
Alright. Is there a method we haven't tried that uses two sides? Is there a method we haven't tried that uses two sides? Well, we have side. So that definitely has two sides. We have side angle side. So there's our sides. Okay? And we already said that angle side doesn't work, so angle side angle has two sides. It doesn't use two sides, it uses two angles. Okay, we need to explore two angles. What possible ways are there? Well, we're going to look at angle side that works. Okay? As. And then we have angle side angle. So both of those ways are going to be legitimate ways to work. So having two angles, having two of the angles with the non-side in between them, or having two angles having the side between them, will conclude. And we could bust out with a compass saying like, hey, if I have this angle and I have this angle that we know, and I know I have this side. If I generate this angle, and create the side as another one, there's only one triangle. Or if I have this angle, this side, and this angle, there's only one triangle that can be generated with that as well if we put them in those orders. So let's try angle side or angle side angle first. So this is, what are we doing here? What are we doing? Is this something I move? How many more are up here? Infinity. Oh my gosh. So angle side angle. All right, let's see what happens here. If I bring this over here, and then I bring this angle here. Okay, so I have an angle on the side and the angle. Notice how these would converge up to get to the point, giving us angle side angle. That's the only triangle that can be generated out of this. And then an angle side and angle. So if I bring this one over, yeah. If I go here, bring that there, notice I could draw this line, and it eventually intersects with this line. So again, angle side angle allows these to work. Okay, I don't know why I have extra lines, but hey, it is what it is. Now let's consider angle angle side. Let's see, how do I want to do angle angle side? How do I want to make this work? How do I want to do this? I don't know. I don't want to make it longer. It's making it longer and shorter. I didn't want it to. So notice how do I want to do this? I can't do it. Oh, I got to bring. There we go. All right, that's kind of a bad rendition. I don't like what I just did. But I do know I have this angle and this angle that are congruent, and there's too much talking going on from the back of the room. Okay, I don't have a good representation of angle side that's going to work perfect. I apologize. So let's just take it. Let's just act like I know what I'm doing for a few minutes. No, but let's just do it between you and I. If two angles and the included side of one triangle are congruent to two corresponding angles, the two corresponding angles and the included side of a second triangle, then the two triangles are congruent. So what does this mean? Bring that out. Ooh, angle side angle. Works. It's Friday, you said? Dude. Oh. Yeah, I voted a few weeks ago. I wish when I turned my ballot in, I wish that would cease to exist any political cartoons, phone calls, commercials, or emails. I wish I was. I wish I could like scan it and say, oh, Chris Sturp is now exempt. So then I get, the laundry detergent commercials that we so miss. So, but unfortunately, it doesn't work. But after today, we should be safe.
Oh, I have a question.
Yeah.
What do you do if like you don't know the candidates? Like for like the smaller things like the city.
A lot of times I vote down party lines, but like the ones like, should this judge stay in? Yes. I have no idea. We did get something on the judges where it was like it was written by Arapahoe County saying there was a committee formed and 6 of the 7 people on this committee said yes. So I was like, you know what, okay. If someone really wants to be on a committee saying, yeah, I want to see if this judge is worth it. I don't know, maybe if I got jury duty and it was like an extended long case, maybe I would say no to that judge just because, I'm that guy. But I don't know. I usually vote down party lines. The hard thing is, there's some people say, oh, this sounds like a really good idea. And there's others where it's like you kind of look at the big picture of what could it mean. And that's hard for me. I don't know. A lot of times I will research something to find out what if there's something at the state level that's trying to be changed for the state, I want to know if there's outside money trying to influence the state. And if there's outside money trying to influence the state, I don't want it.
Russia.
No, not Russia, but like, if some other state wants us to, change which way we drive, we'll now drive on the left side of the road versus the right side, which that's the side I always drive on, is the left side because there's no one on the road that early in the morning. It's much nicer. No, but I just, when there's outside influences for a bill, I don't want it there. Because if it's outside influences, so if you have like, let's say you have company, like let's say Walmart. Let's pick on Walmart just for the heck of it. Let's say Walmart wanted to sponsor a bill. Well, Walmart is sponsoring that bill because they have everything to gain by profiting. Do I really want a company profiting off of me voting for something? Those are just things that I look at. But all right, if 2 angles and the opposite side of one triangle are congruent to 2 angles and the opposite side of a second triangle, then the triangles are congruent. And this one, I don't see it. Where's my stuff? It's not there. So that's angle, side. Going back.
Can you go forward?
Yep.
You go to left.
Left and to the right.
You go back up.
Go back up.
Go down. You go like diagonal.
All right. How could we prove the theorem 4.6? I don't know. Where are we at on this page? I don't even know. It's not on there? Am I missing a page? Oh, wait. I think... Oh, no. That's not on your page. Sorry. All right. We'll go to that one. Yeah, I don't know where that one went. Maybe we decided not to use it. All right. Consider the markings on each pair and then state which postulate could be used for proving the triangles. All right. What do you think? Or consider the markings on each pair of triangles and then state which postulate or theorem could be used for proving the triangle's congruent. Side angle side? Is that all right? So I have 2 sides and the included angle congruent. What about number 2? Yeah, we have a right angle, so we should be going with hypotenuse leg. What about number 3? Side, so we know that. And then number 4? I have an angle, and a side. I don't have the included side, so it's angle, side. as. Cool? What about that one? Have we proven ASA? Angle side angle works on this. We will eventually get to hypotenuse angle. Oh, no, we don't. Never mind. There's no hypotenuse there. There is one called hypotenuse angle that we'll get to. But this is angle side angle. You know that that is as we could draw that. So angle side angle. All right. So given. Anything up there that's sticking out that you should be a go-to? Reflexive. AB is congruent to itself. Love it. Reflexive. All right, so what do we know? We know that, so we can label that angle D. That works. We know that. I do need to, I can't just, I know that, but I have to put it. So being we know that AB is perpendicular to DC, I have to put that, but I have to then label what I know about it. I have to know that angle ABC or ABD and angle ABC are equal to 90 degrees. And that's definition of perpendicular. Amen. Yeah. What do we know then? Do we know enough to prove those triangles are congruent? Side angle side? Angle angle side. Because I know this angle and this angle. I don't have to go and say that 90 is equal to 90. That's redundant, but this is definitely an angle angle side. So I can go ahead and state that triangle ABD is congruent to triangle ABC. And we could state that because we have angle angle side. There's no reason why we shouldn't use that. Yep. 10-point problem right there. 10 points. That's it. Can I finish? Is there one more? One more proof?
You can do ASA.
Angle side angle no, but angle angle side. Because I didn't know this. I didn't know if this was a perpendicular bisector. This perpendicular bisector, yes. I didn't know the hypotenuse at all. But I do know I have an angle and an angle on the side in that order. Alright. This one, we're going to have some reflexive property that could take place. We have some perpendicular that could take place. Looks like we want to prove the smaller of the triangles, ABE and ADE. So we're not worried about the whole thing. So let's put our givens. CE is perpendicular BD. And I'm just going to do like you all do. CAB is congruent to CAD. So that's steps 1 and 2. So 1 and 2 are both my givens. All right, so that should indicate that we know this and this. So let's go ahead and label it. So let's like that the head talk. Angle AEB and angle AED are equal to 90 degrees. Definition of perpendicular. So we can start thinking we perhaps have hypotenuse leg, but we don't know yet. And then we know that CAB and CAD. Gosh, they tell us this. Oh my mama. We don't have a vertical angle. You gotta go the longer step. I'm sorry. Longer step, everybody.
Yo, Angle Bay? No way.
Yeah, babe.
What do you mean? There's an Angle Cab. You know how
What did I do? It is angle addition. It's also linear pair. I'd probably go with linear pair or supplementary angles. So now we know that that's 180. Yeah, that's going to allow us to hit some transitive. All right, so 6 CAB plus angle BAE is equal to CAD plus DAE. Transitive will work. And then I could do substitution. So I'm going to substitute this in here. Hey, sorry to interrupt, but we got 5 minutes left.
Oh, she modified. Is that clock stop?
We have like a minute. No, we don't. We have 1 minute.
We get out of this duster.
I got a minute.
Yeah,
You guys are getting dressed, and I'm sure you're already dressed. Thank goodness. Like, be awkward. All right.
Yes, everyone does.
All right.
Yo, look, it's Angle Bay again. Yo,
Did I already prove that? No, I didn't. Bay day. I did today. Good. Subtraction. All right, so if we know subtraction now, it gives me this and this. Then we can do what our favorite AE. This one got nasty. I'm sorry about that.
Your handwriting's beautiful.
Thanks, man. And then 10. We can prove the triangles are congruent to the triangles because angle side angle. You guys know the next homework, right? Yeah. 4.5. See you guys tomorrow.
Tomorrow.